Okay. Hello everyone. Good morning, good afternoon. I hope you are fine and well today. So this is my second lecture about the integration. Yesterday we covered the exponential function, and today I'm going to explain the integration for the trigonometric functions and using the trigonometric identities to integrate. Okay, so integration for the trigonometric functions and use trigonometric identities to integrate. So in this session, we will learn how to integrate trigonometric functions. You remember this is differentiation here, yeah? Remember this is the cycle for the differentiation. The derivative of the sine is cosine, and the derivative of the cosine is minus sine. Derivative of minus sine is minus cosine, and derivative of minus cosine is sine. Okay, so, and I told you before as well, just remember the derivative of one of them, which is, what's the derivative of the sine, is cosine. This is differentiation, yeah? I didn't start the integration yet about the sine and cosine. So just to remember how to differentiate the sine and cosine. All right, so this is the circle going like clockwise from the right to the left. Okay, now for the integration, because integration is opposite to the differentiation, yeah, then integration uses the same rule but in reverse, yeah, in the opposite way. So if we look at the integration, so we have the integration here, yeah, so this is the integration one, this is the integration, and as you can see, it goes anti-clockwise. So the integration of the sine, x dx is minus cosine x dx. Well, sorry, there is no dx. Okay, so it goes anti-clockwise, so this direction. Okay, so the integration for the sine is minus cosine, integration for minus cosine is minus sine, integration of minus sine is cosine, integration of cosine is sine. Okay, there is also another way excuse me, for you to remember if you want to use it, which is you can write it down like this. So if we write it like this, like as a list, sine x, cosine x, then minus sine x, minus cosine x, and then sine x again. So just to start in order, sine, cosine, then minus sine, minus cosine, then sine again. Okay, and then if we just draw this arrow from the top to below down there, and this represents dy over dx, and the opposite direction, which is from down to the top, yeah, this is the top, from down to the top, this is the integration of dx, and this is exactly same way as the circle we just saw in the slide here, yeah. So the integration for the sine is minus cosine, it's gone. So the integration of the sine is minus cosine, integration of minus cosine is minus sine, and you carry on with the circle. So these are two ways, and there is another way in the next slide. Yeah, if you want to remember it this way, we need to go anti-clockwise. This is for integration, yeah? So if you want to remember this way, is for integration here, and you go anti-clockwise. So that means the integration for the sine is minus cosine, integration for minus cosine is minus sine, integration of minus sine is cosine, integration of cosine is sine. Any way of them you want to remember, that's fine. Okay, right, so we need to go anti-clockwise. This is just an example to show you like the integration of the sine. Yeah, this is the sine here. Integration of the sine is anti-clockwise, which is minus cosine x. Sorry. Plus c. And the integration for the cosine, which is the other one, integration for the cosine anti-clockwise is sine. So integration of cosine x dx is sine x plus c, because it's indefinite integration, there is no limit in it. Right, generally we can say that the integration for sine kx, so k is like any number, like 5, 3, 1000, whatever. Okay, so the integration for sine kx dx equals minus, yeah, don't forget that minus here, minus cosine kx divided by k. So that means divided by the derivative of kx, k of x. Okay, so if we have, for example, I'm just going to do an example here, integration for sine 3x dx, this is going to be, the integration of the sine is minus cosine, and the angle here you put it as it is, 3x. Okay, and then we divide by the 3, which is the derivative of the x. Okay, so we'll divide by 3, and then don't forget the c. C is very important. You will lose 1 mark, I think, in the exam if you forget to put it. Same thing, we have integration for cosine kx dx, means a number multiplied by x. The integration for the cosine is sine. Yeah, remember we have sine, cosine, minus cosine, all these x, and then sine x here. So the integration for the cosine, the integration goes this way. Okay, for the cosine is sine. So integration for cosine kx is sine kx divided by the derivative of the x, which is k. Okay, plus c. So generally we can say this, yeah, this is the minus, don't forget it. Okay, and as for the exponential, you be careful applying this to sine f of x or cosine f of x for a general function f of x. So it only works for the function when it is kx, yeah, like a number multiplied by x. Right, this is just an example, yeah. So sine 5x dx, if I'll just do it here, sine 5x dx, then the integration for the sine is cosine, minus cosine, sorry, integration for the sine is minus cosine. So this is going to be minus cosine 5x divided by the derivative of x, which is 5, plus c. Right, so this is the first one. This is for A. Well, you will have the answers at the back as well. Yeah, there you go. So minus cosine 5x over 5 plus c. But for the second one here, the integration for the cosine is sine. Yeah, so it's going to be sine 2x divided by 2, which is the derivative of 2x, plus c. Okay? Right. I'll have a look. Anyway, this slides it's on the VLE. So if you want to look at the slides itself without the video, it's on the VLE. Okay? Right. Integrating using trigonometric identities. So these trigonometric identities, which we have done them before, it's the double angle formula. Identities, sorry, we used them before. And we're gonna use them when we have integration for sine squared, cosine squared, or sine x, cosine x. So in these three cases, you will use the trigonometric identities. Right, I'm just gonna write the identities here before I move. So the trigonometric identities, we have sine 2a equals 2 sine a cosine a, and I'll show you as well how we get these. So this is one of them, and there is a cosine 2a, which is cosine squared a minus sine squared a. Okay, this is with the three lines here because they are identities. And the last one is tan 2a, which is 2 tan a divided by 1 minus tan squared a. Right, so these are three identities. I will show you now through the slides and how it works. So, for example, some integration problems, you maybe need to use the trigonometric identity. For example, the integration for sine 2x, cosine 2x dx. So as you can see here in this integration, we have sine and cosine. All right. So in these cases, if you have integration for sine multiplied by a cosine, then or sine squared, like this one, yeah, or we have integration for sine squared or an integration for cosine squared. So in these three cases, yeah, we will think about the trigonometric identities to help us with solving these questions. Right. Before I move there, I'm just going to write here on the board, excuse me, and excuse my writing as well. Okay, let's say, so if you are given a tricky trig functions to integrate. So for example, like the integration for sine squared or integration of cosine squared, yeah, x dx. Doesn't matter if it's x or 2x or 3x, what we are looking at, is it sine squared, is it cosine squared, or integration of sine x cosine x dx. So basically, if you are given sine squared or cosine squared or sine cosine together, multiplied together, then you will be able to simplify it and solve it, to simplify it using one of the double angle formula. Double angle one of the double angle formula, one of the, oops, it's gone. Oh, it's gone. Okay, use one of, I'm just going to carry on, the double angle formulas, okay, which is, as I said, wrote it down earlier there, sine 2a is 2 sine a cosine a, and the other one is cosine 2a, which is cosine squared a minus sine squared a, and the last one, which is about the tan. So tan 2a is fraction line 2 tan a divided by 1 minus tan squared a. Okay, these are the double angle formulas. Yeah, so if we have any sine integration for sine squared or cosine squared or sine cosine, then we can use one of these to help us. Okay, and you can find this on page 343. Yeah, it's on page 343. I think. Yes, or no. No, actually, not 343, sorry. Page 343 is questions. I forget about what's 343. I forgot what was there. Page 343, it has exercise 4.1, which is, yeah, you can do questions of that on exercise 4.1. It's nothing to do with this double angle formula. It's for what I explained yesterday in the other lecture. Okay, so take it off for now, not to confuse us. Right, and also just to let you know, this, the green, yeah, for the cosine 2a, it has two different way, like it depends how we arrange it. So cosine 2a is cosine squared a minus sine squared a, and also by rearrange we can get cosine 2a is 2 cosine squared a minus 1. Okay, well, that's in the book. You can show, maybe I can show you in the slides if that's explaining. Right, so this can be another form, like cosine 2a is 2 cosine squared a minus 1, and it can be like cosine 2a is 1 minus 2 sine squared a. Right? So the cosine 2a, it has the different forms, so it's all the same. Right. Let's go back to the slides. Right, so for those problem, you must decide, like what they mean, those problem means when you have integration for sine squared or cosine squared or sine and sine multiplied by cosine. So for those problem, you must decide which identity to use and then apply it to simplify the integral. So you look at your question and you need to decide which one of these three identities to use. Okay. For example, we have the integration for sine 2x, cosine 2x, dx. Yeah? Right. Sine dot cosine multiplied by cosine. So does it have anything to do with the tan? No. So the tan 2a, it's not going to be useful to help with this question. Right. If we look at the identity for sine a plus b, which is sine a cosine b plus sine b cosine a. We did this last term, yeah, before Christmas. So that's a plus b. They have two different angles. If these two angles are the same, yeah, like in this case here, so this, like, for example, this like a and this is b. So if these angles both are the same, that means we can say it is sine 2x plus 2x. It's like saying sine a plus a. Yeah? It's like saying sine a plus a, which is sine a cosine a plus sine a cosine a. Yes? And therefore, if we add them together, let me just write it down, maybe on the board, just to, yeah. So if we have, in general, we have sine a plus b equals sine a cosine b plus cosine a sine b. So that's what we did before, last time before Christmas, yeah, about the double angle formula. If these two angles are the same, so in that case, sine a plus a, because it's the same angle, this will be sine a cosine a plus cosine a cosine sine a. Right? Now, if we look at them now, we have a plus a, so that's sine 2a. So sine 2a equals what? This is sine a here and sine a here. And there is cosine here and cosine here. So we have 2 sine a and 2 cosine a. So we can just write equals 2 sine a cosine a. Yes? Say yes. Good. Now, according to this, if my angle was in the previous question, the example we were doing, it was it 2x? Yeah, or x? Oh, I forgot. If I will go back, this will disappear. So I need to start again. So I'm just going to carry on. So if the angle was 2x, then I'll say sine 2x plus 2x equals 2 sine 2x. Yeah, this 2 here is for the angle. The 2x here is the angle itself. It's called 2x. Cosine 2x. All right? And if we add these 2x, so 2, yeah, I'm here now at the beginning again. So if we add 2x and 2x, that's 4x. So therefore, sine 4x equals what? It equals 2 sine 2x cosine 2x. Okay? And what else? Then if I want to find only sine 2x cosine x 2x, I will divide by this 2. Yeah, I will divide by this 2. So therefore sine 2x as the angle, cosine 2x equals sine 4x divided by 2, which means 1/2 sine 4x. Yeah? Right. Go back to the slides. So it's right. Okay. So this is, I explained it on the board already, so I'm just gonna go through the slides here and see what's there. So sine 2x plus 2x, it's gonna add them together, so that's gonna be sorry, sine 4x equals, as we said, there is 1 sine here and sine here and cosine and cosine, so it's going to become sine 4x because we add these together, and there's going to be 2 sine 2x cosine 2x. And so why we are doing all this thing? Because we just want to use something instead of this. Okay, something to replace by this. So we end up with sine 4x divided by 2 equals sine 2x cosine 2x. So instead, in the integral, we will use this term instead of this. We'll use this term, the pink one, instead of this bluish, light blue. So see, so we replace this form by sine 4x divided by 2 dx, and now it will be easy. So to integrate this, this means 1/2. We can take it outside, and this and then we integrate sine 4x. So sine 4x is 2 sine 2x cosine 2x. This is an identity. Okay. So now, what's the integration for the sine? The integration for the sine is minus cosine. So that's why this is minus cosine. What's the angle? It's 4x divided by 4. Yeah. And we already have 2 outside, or 1/2. So it becomes 8. I'll explain this step if you need. So this means you can write it like integration of sine, well, 1/2. Or even you can put the half outside if you want. It's all fine. So this equals 1/2 integration for sine 4x dx. Okay, and this will be 1/2. The integration of the sine is minus cosine 4x divided by the derivative of 4x, which is 4. And this is multiplication here, yeah? This 1/2 times minus cosine. So the answer will be minus cosine 4x divided by 2 times 4 is 8, yeah? And plus c, which is here. Okay? Happy? I hope so. These are 2 questions now for you. I will explain it for you as well. So we have, okay, before I explain this, let me just show you, well, tell you something. Okay, here if we have sine x plus x, then after we work it out, there's going to be 2 sine x cosine x, and this end up with sine 2x equals 2 sine x cosine x. If I have sine 2x plus 2x, basically that means sine cosine, and it means sine 2x and cosine 2x in the question of the integration. So sine 2x plus 2x equals 2 sine 2x cosine 2x, and this will be sine 4x, which is 2 sine 2x cosine 2x. Another example, don't get bored. Wait. The next one is sine 3x plus 3x. In this case, it's going to be 2 sine 3x cosine 3x. And that's will add up to 6x. So sine 6x equals 2 sine 3x cosine 3x. Okay, and so on. Yeah, and add another one. Let's do sine. If I use, it doesn't write here. Let's try. So sine 4x plus 4x, this will end up as sine 8x. Yeah, this will, it's going to end up as sine, I changed the color actually, I didn't change the color, why? Forgot. Right, so sine 4x plus 4x, because I don't have space underneath here, so I'm just gonna write it next to it, equals come on, right, sine 8x. Yeah, this is 4x plus 4x is 8x, and this is going to be equal to 2 sine 4x cosine 4x. What I wanted to show you from all these writing and colors and explaining that if you have it, if you have in your question in the integration sine x cosine x, then the rule you're going to use to integrate is going to be, let's put this in green, it's going to be 1 over 2 and sine 2x. Yeah, so it's always, you will have at the top, at the numerator at the top, double what you have in your question. In your question of the integration, if it's sine x cosine x, there's going to be sine 2x. If your question has sine, if your question, oh, it's gone. Okay, if your question has sine 2x, if your question, if your question has sine 2x cosine 2x, yeah, dx, then sine 2x cosine 2x, it's going to be equal to 1/2, then what is it, half sine, double the angle you have, so it's going to be sine 4x. If your question has the angle as 2x, when you change it here in this form, it's going to be sine 4x, yeah, divided by 2. And you put this in the integration to use it instead of the sine 2x cosine 2x. Okay? If your question was integration of sine 3x cosine 3x, and of course you should have dx in all of them when you have the integration. Then you will use the formula of sine, double your 3x, which is 6x, divided by 2, okay, dx. If you're, I hope you understand this now. If you have the integration of sine 4x cosine 4x dx. This is going to be integration for sine 8x, double the 4x, divided by 2 dx. And then, as I said, when we integrate, we can take the 1/2 outside, or even if you leave it inside the integration, it's not going to affect. You can just multiply it by the others. Okay, I'll go back to the slide. Ta-da! Okay, so by looking at this, I have sine x and cosine x. Then my rule should be sine 2x, the double of the x, which is sine 2x divided by 2. And then we multiply it by 3 actually, because we have a 3 at the numerator at the top. And for the second one here, because I have a 3x here and 3x here, then what I'm going to use instead of this is 1/2 times sine 6x. Yes? Ta-da! So, what's happened here? Excuse me. We put the 3 outside, so this 3, we take it out. Even if you leave it inside, it's fine, it's not going to affect it, but it's easier if you take it outside. Then we end up with integration of, we replace sine x cosine x dx by this, yeah? So because sine x, well, now you learn this, I hope, equals 1/2 sine 2x. Right? So we used this here instead of the sine x cosine x dx. And now the integration for the sine is minus cosine 2x divided by the derivative of the 2x. So we divide by the derivative, well, this is the 2x here, the derivative of 2x is 2. So we divide by the derivative of the 2x. And this to here, this to here, yeah, it is outside now. So the yellow one just go out because it's like 1/2, it doesn't matter, right? And if we want to finish this off, we can say this is equals minus, sorry, 3/4 cosine 2x plus c. Okay, so this is for the 3x. As I said, it's going to be double. So sine 3x cosine 3x, it's going to be 1/2 sine 6x, yeah, yeah, sine 6x, well, half means you divide them all by 2, same thing, you just put the divide by 2, right? So instead of writing all this, we replace it with this, so it becomes integration for 1/2 sine 6x dx. We put the half outside by outside, yeah? So, and now the integration for the sine is minus cosine, yeah? So this is minus cosine, the 6x, this is the angle, and then divided by the derivative of 6x, which is 6. Ta-da, ta-da. Okay? Happy, happy? Plus c. I hope you understand this. Right, so that was when you have questions, integration for sine, cosine, dx. Okay. In case you have integration for sine square x dx. Okay, so for sine square x dx, the identity for the sine cosine plus cosine sine is not going to be useful for us because we want something that has sine squared. Okay, so in this case we will use this one. This is going to be helpful for us because we learned before cosine a plus b or a minus b, it depends which sine is, it's cosine cosine plus or minus sine sine. Yes, that means it has, if this, so this is in case the angles are different. As I explained before, let's go to a new one. So if we have cosine A plus B, this is going to be cosine A cosine B. Yeah, if it's plus here, there's going to be minus here. Sine A cosine, no, sorry, sine sine. Okay, so sine A sine B. Okay, so that's if the two angles are different. If the two angles are the same, then in that case it's going to be cosine A plus A, which is cosine A minus sine A sine A. I get confused now. Okay, if we add these two A's together, that's 2A. Yeah, so cosine 2A equals, well, I have cosine A, that's cosine squared, right? And sine A times sine A is that sine squared. So I will have cosine squared A minus sine squared A. Happy, happy? Yes, you are. You can't be not happy. Okay, so cosine 2A equals cosine squared A minus sine squared A. And if we rearrange, we can find like sine squared equals cosine squared A. Yeah, if I rearrange, let's go there. So if I move the minus sine squared to the other side, there's going to be sine squared A equals cosine squared A minus cosine 2A. Right. What I can do here is cosine 2A, we can use the sine square plus cosine square equals 1. Yeah, we know the identity. We did that before, that sine squared x plus cosine squared x equals 1. Therefore, sine squared x is 1 minus cosine squared x, or cosine squared x equals 1 minus sine squared x. It depends which one you want, right? So in this case, we can use, instead of cosine squared A, we use 1 minus sine squared, and we'll arrange it. I'm not going to go through this now. I think it's going to come on the next slides. Okay, so let's go back to the slides. Back to the slide, right? Okay, so this is just to say like cosine A plus B is cosine cosine sine sine, and then if it's same angle, then that's cosine 2x is cosine squared minus sine squared. That's what I explained on the board. And we reach the identity that cosine 2x equals cosine squared x minus sine squared x. We need to get rid of cosine squared. Yeah, so that's why I said we can use, instead of this, we can use 1 minus sine squared to get rid of the cosine squared, as we don't know how to integrate it. Okay, so we need to get rid of the cosine squared because we don't know how to integrate this, right? So we already know that sine squared plus cosine squared equals 1. That was from the term 1 we did before Christmas. Okay, so we can say cosine squared A is 1 minus sine squared A, and if we substitute that, instead of the cosine squared, we use 1 minus sine squared x. So we have cosine 2x is 1 minus sine squared x minus sine squared x. So that will be 1 minus 2 sine squared x. Yeah, because minus minus is minus 2 sine x, sine squared x. So this is another identity. Ta-da! We can use. Happy? Yes, you are. Right, example. So now we know if we have sine squared, if we have integration for sine squared x dx, we use from cosine 2x equals 1 minus 2 sine x, 2 sine squared x, we rearrange to get the sine squared, which is lead to cosine 2x, yeah? So sine squared x equals cosine 2x minus 1 divided by minus 2. So when you see integration for sine squared, you will use this integration instead, which is cosine 2x minus 1 divided by minus 2. Okay, to make things easy to work out. Right, so we replace the sine squared x dx by cosine 2x minus 1 divided by minus 2 dx. Sorry. And we can take the 1 over minus 2 outside, yeah, as a number like minus 1/2 can go outside, and then we integrate cosine 2x minus 1 dx. So minus 1/2 went outside, so this goes out, this goes out, which means this minus 2 at the denominator means it's minus 1 over 2, yeah? So that's goes out here, and we're left with integration for cosine 2x minus 1 dx, which is easy. What's the integration for the cosine? What's the integration for the cosine is sine. So that's sine. The integration for the cosine 2x is sine 2x divided by the derivative of the x, which is the derivative of the 2x, yeah, which is 2 here. We divide by 2. Now minus, what's the integration of different color? What's the integration for 1? It's 1x, yeah? So the integration for a constant is x plus c. So this will be as a final answer, if you want, as minus 1 over 4, because minus half times 1/2 is minus 1 over 4 sine 2x minus x plus c. That's it. Okay. Right. Ta-da. This is examples, which I already explained. I don't need to keep saying things, don't I? Right. So now we know for the sine squared what we use. We use cosine 2a. Cosine 2a minus 1 divided by minus 2, yeah? So all this, so we reached this, the identity here for the sine squared is cosine 2x minus 1 divided by minus 2. We put this instead of the sine squared x dx, and we integrate it as the example I showed you in the previous slide, and that's the answer. For cosine squared 2x, right, for the integration of the cosine squared 2x, it's again using the cosine 2a, and cosine for x, it means it was cosine 2x plus 2x, yeah? So that, oh, sorry, I'm writing, saying there, okay, change. We'll do it again, different color, yes. So cosine 4x means cosine 2x plus 2x equals cosine 2x. Oh, I don't have space here. Anyway, so it's going to be cosine squared 2x minus sine squared 2x. So cosine 4x is cosine squared 2x minus sine squared 2x. Okay? And therefore, cosine squared 2x, therefore cosine squared 2x, this one, it's going to be equal to cosine, it's going to be equal to cosine, what is it, 4x plus sine squared 2x, cosine 4x plus sine squared, I don't have space here, 2x, okay? And again, if we use the identity for the cosine, I think, and we get cosine 4, yeah, so we use the identity here, look. Instead of sine squared is going to be 1 minus cosine squared 2x. Therefore, cosine 4x is 2 cosine squared 2x minus 1, because we have, this is minus cosine squared minus 1, it's going to be plus cosine squared, and this is another cosine squared, so that's 2 cosine squared 2x minus 1. This is minus times 1. If you just follow them, it's very easy to follow, and you will reach this form. Okay, and we replace it, instead of the cosine squared, we replace it by cosine 4x plus 1 over 2 dx. They just put the 1 over 2 outside the integration, and then we integrate. The integration for the cosine is sine, so integration for cosine 4x is sine 4x, yeah, and then we divide by the derivative of 4x, which is 4 here, and plus the integration for 1 is x, and therefore plus c, and so this is going to be, if you want to write it as well, as 1 over 8, because 1/2 times 1/4, 1 over 2 times 1 over 4, yeah, is 1/8, 1 over 8 sine 4x plus x. Actually, this x is x over 2, yeah, so half x plus c, because the half is outside the integration, so that includes the x, yeah? Or if you want, just leave it as it is in the slide, and you put the 1/2 outside, and then you work it out. Happy? I hope so. Well, that's it. Yeah. So that's the end of this lecture today. I hope you understand it, and good luck with your self-study. If you have any question, well, let me know. Okay, see you tomorrow. Bye.